Well, there's actually a talk I suggested David Rousseau to give, and then he didn't come, and then Beck suggested me to give it. So basically, dug my own trench here. That's a summary of a workshop series we have organized in the last few years, and it's thematically so close and covers quite a few things. I'm gonna go through. This will not be a very scientific talk because it's almost impossible to, well, it is certainly impossible to give a proper in-depth scientific summary, but I'm gonna try more to highlight the hottest topics and also the mode of the workshop for learning, and it was called Learning to Discover. So this series and took place in the Institut Pascal in Saclay as a workshop series. Now, this is a new institute that has been established in the Paris-Saclay center. So that's, I give you this for further reading. It's in the south of Paris. And it's, speaking in the words of the director, who's actually coming from the physics part of it, he says, like, it sees itself as not at the end of the scientific process, like usually a conference or a publication is, but at the beginning of the scientific process, meaning a place where you discuss and start developing a research rather than presenting, see what I've been doing, etc. It's not entirely as flashy as it looks at this rendering pictures, but the building is quite new. So. And it's hosted with a quite broad of scientific council to which you can submit proposals for 2-week workshops. And the focus here is really on workshops. So our next call is up in October for the 2024 workshops. Now, this was the Learning to Discover series, which covers quite a lot of topics also that we have touched upon today. The first one was in 2019, July, on real-time analysis. So very touching upon also the topics you've seen today by Thomas in the morning. Then the second part, I call it the TrackML aftermath workshop on advanced pattern recognition, are now concluded with several attempts in the Learning to Discover final workshop plus conference. You can see the reasons for the shifts were the current or that time COVID numbers. You can also see how sort of now we tolerated way more than at our very first forced shift on that. The workshop style was very much non-conference like, although we concluded it with a two-day conference, which is a bit untypical for the institute. By that I mean that you really try to invite on invitation only, and also then at covered cost, people that you would like to come together with a very light program and a lot of time to discuss and hopefully give time also to develop basically scientific ideas. So just to give you an idea, this was the Learning to Discover the advanced pattern recognition timetable, where you practically could expect 2 contributions per day, or maximum 3, and the rest was time you should sit together or even have follow-up and do work. So the very first one was the real-time analysis workshop. I'll point you here to the one of the summaries from Baba, but you have also seen today, basically it's touched upon again on the talk from Thomas on real-time analysis, basically very fast throughput on the fly understanding of the events. Got this from the workshop summaries. It seems to really have worked there as well. I was not present at this one, so I cannot really give you a very detailed summary, but from what I've heard and seen, there was a lot of white, or in this case, blackboard discussions. So it seems like this format is really inviting. The second one, I would call it TrackML aftermath workshop on advanced pattern recognition. You click here, you can always access the agendas and look at them. Practically had a real strong focus on outcomes of the TrackML challenge, so the machine learning challenge we've done with this dummy tracking detector, covering classical approaches, GPU accelerated approaches, graphs, graph networks. Those the first, and we will see today, this week, more updates on the Exatrack project, hashing techniques, encoder decoder solutions, etc. Also then covering how we would do inference with classical algorithms or with a deep network. So this was basically the topic space of this first one, followed up by also having a contribution on the attempts using quantum computing on the TrackML data set. So be invited, follow it up and look at it. At that time, pre-pandemic, we did not have recordings. Now the last workshop, everything is recorded, so also something we learned. But just to summarize, also this workshop, so see the format seemed to have really inspired and invited people to use the time to sit together and develop something, even with outcome. So this was one of the things I think which was discussed here, was led to this picture. These are two tracks in the Atlas detector that have been reconstructed, not with the Spotify library, but with something very similar. We have tried this with the Spotify library. That's with I think the nearest neighbor hashing library from Facebook, but pretty much the same. One other topic which was touched upon, and I will come to this a bit later, also in the context of this last workshop, is having data sets for algorithmic research. So the TrackML data set has been and is still very heavily used and accessed by people in many different approaches. And we started a bit earlier, but also within the advanced pattern recognition on the follow-up data set, which basically takes the simplified detector from the TrackML into what we now call the open data detector that has a full Chean simulation. And this was the status basically back then, and we touch upon this later. Now, finally, we concluded this series in last month with the workshop called Learning to Discover, to wrap everything up, that had 3 sub-workshops, one on representation learning, one on dealing with uncertainties, and one on generative models, and then finally on with the physics and AI conference to follow this up. There have been always nice summaries of all these, so I'll point you to this, but I'll try to highlight a few things. Savannah, who's here, can probably do it again, but I would rather invite you to look at the recorded video, because that wouldn't be too fair. I have summarized nicely the representation workshop. There was a lot about graph networks in track and vertex reconstruction. I will really not go into that at all here, because we have several talks in this conference, plus we have the 190 people at registered graph network workshop on Friday. This is interesting. One thing which I found very interesting was the contribution from Alvaro from DeepMind on really showing that graph networks practically can be so strong in generalizing, and on the other hand, most other ML models can actually be seen as some specialization or representations of graph networks. And this is this work presented by him from Google Mind, where they practically use one graph network, this graph network design, and use it in many different applications. This is simulation of water, of meshes. This is something where you simulate even a detector. I will come to this, or the movements of objects. In a encoder decoder architecture with of course the possibility that you can create a simulation engine out of this. And the overall idea, if you follow, go to this talk, you can actually see also some videos, is to try to find a general, basically a general purpose physics simulator that learns everything from first principles, and which you can then also use to actually do this design of detectors. So this is one example they have done. The idea, the question here was like, okay, there's some water liquid coming out here, and I have two pools, and I want to have the water be split to the same amounts into these pools. How would have how this surface has to look like in the best idea? So you basically have an inner loop, which I've shown before, and an outer loop with an optimizer. And since this is differentiable, you basically can run it in an optimizer and then come up with some final design, which does way better than a step-by-step simulation. So that's actually quite neat to see, and I'll come to that a bit later. Second workshop, mini workshop, was on dealing with uncertainties. Also a topic that came up in the conference, final conference, to quite an extent. The question how different families of uncertainties basically are to be understood in a machine learning context has been, I think, very broadly discussed here, and I'll come to one discussion point in a slide later. We can have a look at a specific example. And finally, a workshop more on the generative models, where closing back the gap to the open data detector, we are basically seeing the start of a new challenge, so machine learning challenge for HEP, which is a fast Carlo simulation challenge that basically tries to, in a framework of a machine learning challenge, let people present their models to do fast shower simulation in 3 different steps with 3 different data sets that are in the same format but differently complex. And you can follow this up here and see where this hopefully would lead to. Lots of discussions here, graph network discussions with people from Google Mind. In detail, we have discussed, this is probably to be seen as an input for the Friday workshop. What's next to be done on the graph networks? One topic we discussed quite a bit is the sharing of nodes, because in dense track environments, this is something which you probably will have to start allowing, that you have built up your graph from hits, but then you basically analyze the local neighborhood and you see that it's dense, and you will have to start, if you want to have if you have a reality of really 2 tracks sharing hits here, you'll have to modify the graph. So this was one input from this. On the uncertainty discussions, we had quite an interesting, for us, I think for the high energy physics community, something which we always do, think about that. So you have a generator A or and a generator B, and we build our systematic uncertainty by running it once with generator A and run generator B, and we kind of always assume or hope that the true value sits somewhere in this plane that, or in this case, simplified region that is spun off by these 2 generators. Now, if you have run this in some sort of model convergence, trying to push your systematic uncertainty smaller and smaller and smaller, you might actually doing you not a big favor, because you could actually really remove it in 1 dimension, such that your true actual value gets pushed out of it. So good discussion on how to do this. On the generator workshop, we had a good discussion on how we actually potentially fool ourselves if we use full simulation to determine our models. That shadows quite a bit was actually going on, because we built our full simulation with just looking at sensitive sensors and use that information. Basically, don't look at dead material, for instance, here. One direct consequence, we made a kickoff meeting as a preparation, or a IPA meeting as a preparation for the kickoff meeting at CERN, to extend finally the open data detector with a calorimeter, and we had some input from our side to this, so it happened then in parallel, but it was actually quite a good hand in hand. Finally, the physics and AI conference, I will flash a few things which I found interesting. If you remember what I talked before on designing your experimental setup using machine learning techniques, well, that's the overall goal of the mode collaboration, and Tommaso gave us his insights of how they would like to do this. Basically, that you build an entire pipeline with a full differentiable set that you then use with an optimizer to design your experiment for the optimal outcome. Well, that's a far shot, of course, because you can imagine how complicated these objectives are. We had discussed this today with the GPUs. Money, availability of the product, all of these things at the end, if you want to optimize, should go into that. And as we discussed the coffee break with Paolo, not everything is differentiable then, so you might up in a bigger problem here. Anyhow, they showed it on a case study for a muon detector that you can do this in a simplified pipeline, and as complicated things are, they always start simple and you build up upon those. So that's interesting. It brought me back to something we had tried at the very first one, at the advanced pattern recognition workshop. Sabrina and I had tried to basically let a particle tracking detector be built by an AI module with some success. Let's put it that way. Yeah. Well, that's a simplified, that's poor man's approach first, module intersection detection, then the module learns, the agent learns to place modules, and we gave some constraints. They should be layers. Well, that's somewhere where we stopped, but it was good to see that we were not entirely far off with our ideas a few years ago. One thing I would like to really have a focus point on was one of the inventors of scikit-learn came and gave, I think, a very educational talk on how and why scikit-learn became what it is. It's the most successful, most used software by data science expert. Particular, this is from Kaggle, but it will be very similar. And he gave basically a review of that. Well, it's easy. The winner, the story is always told by the winners. Yeah, that's the survival bias here in action. With a recipe of how to write scientific software that is actually sustainable. A lot of it is common sense, but it's good to see that is actually a path to success. With, I think, 10 conclusions or 9, if I can count. Simple, consistent API, a rich feature set, but yet a clear scope, contribution guidelines, automated review release processes, documentations and examples. Don't own the project. That is hidden here means you should always give credit to the people who have actually written the code. Open community, fight your code complexity wherever you can and communicate. Very, let's say, yeah, may sound trivial approaches, but I found that interesting. That it's really good practices that you can see. And then some other highlights. I think that was quite an interesting talk, a historical talk from Bruce, who was actually the first person published neural networks in HEP for reconstruction, who happened to be at that time also in Saclay and still in the Paris area. So he gave us a nice historical talk. And then more contributions, which I've also found interesting in the interpretability and the sort of also danger of just using AI modules without focusing on let's say the the way to understand the limits, put it that way. One but final slide. The institute was or is intended to be at the beginning of the scientific process, but also we inserted the possibility that the end of the scientific process, which is the publication, is also possible with the CSBS special issue on advanced pattern recognition or advanced tracking algorithms. And this is so far filled with 2. One is to come and one in planning. So contributions also there. You can see that such a workshop can also basically span from the beginning to the end of the scientific process. Anyhow, that's my conclusions for this. I think personally this sort of workshop model is very, very useful in some well-prepared way to spark off developments. This time together was great. It was also great to see everyone again, and it has been used, as I hopefully could show you. And it has been also successfully deployed somewhere else. For instance, people who know the Hammers and Nails or the Kavli Institute in Theoretical Physics, they have done these sort of programs for quite some time already. Voila.
Okay, thanks. Okay, so there is time for questions here in the room, and also people on Zoom. Just raise your hand. The room. Go ahead.
So I'm Joe. I have a comment and a question. The comment is that at the Electron Ion Collider, we are also looking into machine learning applicability for experiment design and optimization. So I think that's another area of collaboration between the more typical HEP and nuclear physics community. Not as free as your example. I have some more constraints. The second thing that I wanted to ask is, so how do you can you maybe comment on what is the successful, or what is your experience in how to develop these workshops that have more of a discussion time? Your comment here is that, or your comment that you made was that it has to be sort of well planned to make this a success. So could you comment on what that planning process is like, or what the needs are?
Yeah, having the right people. The invitation process So we had an invitation process where we focused on topics with experts, but at the same time had any expert that was invited was also invited to bring which we thought young, hopefully younger collaborator that would also be covered by the invitation, to basically bring a community together where you have a good mix of experts and people who want to become experts. I think that's a very good starting point for using discussion time, or even sit together and code something. By the expertise and the people who want to get the expertise. So that's certainly part of the planning process. One key point from my point of view is the ability to also have the time for every one of us has projects running here and there. And if you are at the conference, you can't do any of that. Or you sit with your laptop and you do your email. No, I'm not pointing at anyone. Or you do your emails next to it, or your whatever you need to do. And that is kind of counterproductive to what you want to do here. But then if you have a window slot of the afternoon, an hour and a half, whatever you want to do, then people often do their admin work or whatever home institute associated work then, and are way more present in the actual workshop. So yeah, there's quite some engineering on that level. Let's put it that way.
So that here in the room we have also some blackboards, so if you want to make your drawings, so you can. Well, I have to say that at least one of the things I like of this series of connecting the dots is that the talks usually are quite long. People can explain, and then there is 5 minutes program also to ask questions and to debate. Not like in many of the conferences that there are 2 minutes talk and 2 minutes for questions. So there is no way.
Exactly.
It's going quite well. Any more comments or remarks to Andy? So do you think the artificial intelligence can design a detector for us?
So coming back to this, we had actually covered in a long discussion then, because what we did here then, with our plan we had was a multi-staged system and not a single system, because at the end, if you want to design a HEP detector and you really want to do it for precision physics, you need to run at some point GEANT. Now having this iteration here running GEANT each time on big statistics and feed it in with some sort, that's the idea of the differential programming of somewhat changing parameters. That's I'd say a very difficult task. Yeah. So what we thought is trying it. That's what we discussed also with the mode collaboration guys. Is having simple blocks which build upon each other. But then that's one part of the story. Yeah? If you think this was really already, there's some silicon, and we had to put in things like, if you increase the resolution, you need more cooling, so the model gets heavier. All of this you would have to code up. So there's a lot of engineering you need to put in that this makes sense. And if you don't do a lot of constraints, you get some modules flying in the air. Yeah, all right.
Okay. So are there more comments or questions to Andy? No, nothing in Zoom either. I can see any questions. Okay, so let's thank Andy again.